In this lesson, we're going to cover Unit 5, Acquisition 3, Identifying Redox Reactions. So these should be pretty easy to identify. Redox reactions involve a change in oxidation number. So all you have to do is go through the reaction, assign oxidation numbers to each element. Then we're going to compare. If there's a change in oxidation number, it is a redox reaction. If there is not a change in oxidation number, it is not a redox reaction. So let's look at a few examples. Same question stem for all three. Let's determine if the following reactions are redox. Reaction A. Sodium plus zinc iodide produces sodium iodide plus zinc. So the way we're going to approach this problem is go through and assign oxidation numbers, and then we're looking for a change. Elemental sodium by itself, not part of a compound. It has an oxidation number of 0. Iodine is a group 7 halogen. Halogens have an oxidation number of -1. I have 2 iodines, each with a -1. Think of that like a -2. To make that neutral, zinc has to be +2. Sodium is a group 1 metal. Group 1 metals have a charge of +1. Again, iodine is a halogen. Halogens have an oxidation number of -1. Zinc, in its elemental form by itself, not part of a compound, has an oxidation number of 0. So now we want to compare our oxidation numbers and look for a change. So I see that sodium has a change in oxidation number, and also zinc has a change in oxidation number. So yes, it is a redox reaction. For extra practice, let's figure out which element is oxidized and which element is reduced. So sodium starts with an oxidation number of 0. And it ends with an oxidation number of +1. Zinc starts at +2 and ends with 0. So, oil rig. Oxidation is the loss of electrons, reduction is the gain of electrons. And remember, electrons are negative. So if you lose an electron, it's like subtracting a negative, it becomes more positive. Sodium becomes more positive, so it's oxidized. It had to lose electrons. Zinc must have gained electrons. Zinc is being reduced. It's going from a +2 down to a 0. So zinc is reduced. If you're gaining electrons and electrons are negative, it becomes more negative. In general, single displacement reactions are usually redox reactions. The big giveaway for me right away when I look at this is elements by itself versus elements in a compound. Elements by themselves in their elemental form will have an oxidation number of 0. They're not going to have an oxidation number of 0 when they're part of a compound. So clearly sodium is going to have a change in oxidation number as well as zinc. Reaction B. So again, to determine if this is redox or not, we need to assign oxidation numbers, and then we're looking for a change in oxidation number. This one's going to be a little bit more involved, so I'm going to write out how I solve for the oxidation numbers. So we need to look at the formula. I have 2 sodiums. Sodium is a group 1 metal. Group 1 metals have an oxidation number of positive 1. I don't have a rule for sulfur, so I'm going to skip it for now. 4 oxygens. Oxygen has an oxidation number of -2. I know that the sum of my oxidation numbers must equal 0. Therefore, sulfur has to be positive 6. When we're determining oxidation number, it's of each individual atom. So for sodium, I wouldn't put positive 2. Each sodium is positive 1. We figured out sulfur is +6. And again, don't put -8 for oxygen. There are 4 oxygens, each with a -2. Let's do the same thing for barium nitrate. Barium is a group 2 metal. Group 2 metals have an oxidation number of +2. Remember, subscripts multiply in. 6 oxygens, each with an oxidation number of -2. In order for this to be neutral, nitrogen has to be positive 10. But don't forget to pay attention to your formula. There are 2 nitrogens. So if I have 2 nitrogens and together they have to equal positive 10, each nitrogen must be positive 5. Each oxygen is -2, and barium's positive 2. Over to the product side. Sodium is a group 1 metal +1. 3 oxygens, each with a -2, gives me -6. Nitrogen must be positive 5. Last one, barium sulfate. Barium is a group 2 metal, +2. 4 oxygens gives me -8. In order for this compound to be neutral, sulfur has to be +6. Remember, you are writing the oxidation number of each individual oxygen. Each would be -2. So now that we've assigned the oxidation numbers, let's go through and see if there's a change in oxidation number. Sodium, +1, +1. Sulfur, +6, +6. Oxygen, -2, -2, -2, -2. Barium, +2, +2. Nitrogen, +5, +5. There are no changes in oxidation number. So no, this is not a redox reaction. Always good to double check, but usually double displacement reactions are not redox reactions. Let's try one more. Let's do a combustion reaction. Methane plus oxygen produces carbon dioxide and water. So we'll start by assigning oxidation numbers. If hydrogen's bonded to a nonmetal, its oxidation number is +1. 4 hydrogens, each with a +1, is like a +4. Carbon must be -4. Diatomic oxygen, it's in its elemental form, not part of a compound, its oxidation number is 0. Oxygen has an oxidation number of -2, but there's 2 of them. Think of that like a -4. Therefore, carbon has to be +4 to get to a neutral compound. If hydrogen's bonded to a nonmetal, like oxygen, it's +1. Oxygen is -2. And again, this would be neutral. 2 times a +1 gives me +2. Oxygen's -2 cancels that out. Do we see a change in oxidation number? Yes, I do see a change in oxidation number. So yes, it is a redox reaction. For that extra practice, let's figure out which element is oxidized and which element is reduced. Carbon starts at a -4 and ends at a +4. I also see a change with oxygen. Oxygen starts at a 0 and ends at a -2. Oxidation is the loss of electrons. If you lose negatively charged electrons, it becomes more positive. Carbon becomes more positive, so carbon is oxidized. Oxygen is reduced. It's reduced from a 0 down to a -2. Reduction is the gain of electrons. If you gain electrons and electrons are negative, it becomes more negative. Before even assigning oxidation numbers, you should be able to identify this as a redox reaction because we have an element by itself. Oxygen in its elemental form will have an oxidation number of 0. It's not going to have an oxidation number of 0 when it's part of a compound. So it's always good to go through and assign oxidation numbers just to be sure. But hopefully the more familiar you get with this, you'll be able to spot some of those tricks to help you identify them a little bit easier.